Welcome, everybody. Let me finish getting situated and then we can begin. As a reminder, if you have questions throughout, feel free to pop them in the chat. I'd rather answer them as we go rather than all at the end. Sometimes that's easier. Also, today is our first lesson. So after today's lesson, there will be, you probably have already seen the first quiz open, but you'll have everything that you need to answer the questions on that quiz, and it will be due on Tuesday next week. Just give me a minute to get situated and then we can start. Somewhere, there it is. Okay. All right. Here we go. Lesson 1. Let's see. Do I have any announcements other than what I said? I don't think so. So I think we can just jump into what we're doing today. We're going to begin by talking about basic operations with customary units. So customary units, you're familiar with them. That's the US system. Things like inches, yards, feet, etc. And we're mostly going to look at the fractional representation of these. And the reason for that is in a lot of technical fields, there are programs which you are probably more familiar with than I am, but there are programs where you need to know how to use or at least be familiar with measuring things in fractional form, such as half inch, quarter inch, etc., rather than the decimal form. So let's start. We are going to talk about linear units primarily. Linear units measure distance. So the ones that probably you have used a lot are inches, feet, yards, miles, etc. So let's just say that we have an inch, such as the one below. And it's broken up into pieces. We're used to seeing a ruler broken up into halves, such as this, half an inch. You take half of a half and you get a quarter, half of a quarter, you get an eighth, etc. And this is useful. If we want to measure something in inches, but 1 inch is too big, we can break it into smaller pieces. So this helps us to get smaller and smaller distances. But it's often the case that we can't measure something in exactly a half an inch or exactly a quarter an inch, etc. We want to add things together or mix the parts of an inch. And so let's talk about how we might be able to do that. Some of this I just mentioned, but let's say that I have 1 inch. So this is representation of 1 inch. And we break it into pieces. If we break it into 2 pieces, then we call each piece 1/2. This denominator tells us that the one whole was broken into 2 pieces. 2 pieces, each having a length of 1/2. Similarly, if I break an inch into 4 pieces, the denominator of the fraction that I use to represent the length of each piece is 4. So I've divided the inch into pieces of 1/4 each. So it's 4 pieces that I've divided the inch into. One thing that's helpful to note here is, as I'm sure you're familiar, one fraction can have multiple names. So it looks like 1/2, for example, right here. 1/2 is the same length. Oops, too far. 1/2 has the same length as 2/4, which means that 1/2 inch piece is equal to 1/4 plus 1/4, or 2/4. So 2 different fractions, but they represent the same quantity. When 2 different fractions represent the same amount or the same quantity, we call them equivalent fractions. That's the mathematical name we give to those. So fractions with the same value, but different names. Okay. Now let's start thinking about how we might compare fractions using that knowledge of equivalent fractions. So another way that we can think about equivalent fractions is that the numerator and the denominator are multiplied by a common factor or a common number. For example, if I want to show that 1/2 and 2/4 are equivalent fractions, so they represent the same number, then I can choose to multiply the top of that fraction, the numerator, by 2, and multiply the bottom by 2, which gives me the fraction on the right, 2/4. Since I multiplied the numerator and the denominator by the same factor, the same number, 2/4 is a equivalent fraction. There's lots of ways we could represent this. So I could choose to say multiply the numerator and the denominator of my fraction by 4 instead, which gives me 4/8. So that says that it would take 4 1/8 pieces to make up 1/2. We can see that here. I have 4 little 1/8 of an inch lined up together, and they together comprise 1/2 of an inch. And we can see that also by equivalent fractions. So that's kind of one a side thing that's kind of nice to note is the bottom of the fraction we said is the number of pieces the inch is divided up into. So if the denominator is 8, and the inch is divided into 8 pieces, the top of the fraction tells us how many of those pieces are being considered. How many are being considered? So here I have 4 1/8 size pieces. We could go further. Divide the inch into 16 pieces, so multiply the numerator and the denominator by 8, giving us 16/8. There are quite literally an infinite number of equivalent fractions to 1/2 that we could come up with by multiplying the numerator and the denominator by the same factor. So these are all different ways to represent 1/2 inch on a ruler, or just 1/2 as a fraction in general. Okay. So now comparing fractions. That's kind of a goal in part for what we're talking about today. In order to compare fractions, it is much easier if the fractions have a common denominator. A common denominator means the same denominator. And as an aside, to answer the question in the chat, I should be able to post the recording by at least tomorrow morning in Canvas, if not this evening. I try to get it up pretty quick. So 1/4 inch and 5/16 of an inch. These are not equivalent fractions. They don't represent the same part of a whole or the same part of an inch. But we want to be able to compare them and see which is bigger and which is smaller. And that's much easier if they have the same denominator or the same bottom of the fraction. So what we're going to do is, let's focus on this smaller denominator. Smaller denominator is 4, and let's ask, what could I multiply 4 by to get 16? So what can I multiply 4 by to get 16? Yes. To get 16. And yes, I see in the chat, y'all are telling me 4. I agree with that. So let's go ahead and multiply the numerator and the denominator by 4. So I get a fraction that has the same value, just a different denominator, or an equivalent fraction. So 1 times 4 is 4. 4 times 4 is 16. Great, we've created an equivalent fraction. And so on the left, we have 4/16, and on the right, we have 5/16. 5 out of 16 parts is bigger than 4 out of 16 parts. So that means this 5/16 must be the larger of the two fractions. So comparing fractions is much, much easier if we have the same denominator. I know some of you are probably very familiar with working with measurements, so this might be a familiar process to you. If you're not, welcome to fractions. Questions on that before we do some more examples? Okay. Let's do the following. Let's identify which of the given measurements is larger without using a calculator. So let's start with number 1, 1/8 of an inch, or 1 3/32 of an inch. We're going to focus on the fractional portions of these. So the 1/8 and the 3/32, because both of them, we're told, we're considering 1 full inch and then another part of an inch. For number 1, oops, let me get a pen, not a highlighter. For number 1, I'm going to focus on the smaller denominator again, 1/8, and I want to rewrite it as an equivalent fraction with a denominator of 32. I'm going to multiply the bottom by 4 and the top by 4. If I multiply the top and the bottom by exactly the same thing, then I will not have changed the value of the fraction any. Great. So 1 times 4 is 4, and then 8 times 4 is 32. Great. So we have a comparison of 1 and 1/8, or 1 and 4/32, and then 1 and 3/32, and we want to ask which is larger. It looks like 1 and 4/32 is larger, because 4/32 is bigger than 3/32, as the numerator is larger. Okay. We can do something very similar for the second one. We have 1/2 and 35/64. I am going to compare those two fractions, and I'm going to focus on the one with the smaller denominator here. So that's the 1/2. I want to multiply the denominator by some factor that will give me 64 in the denominator. So that's 32. If I multiply the bottom by 32, I have to multiply the top by 32 as well. So 1 times 32 is 32. 2 times 32 is 64. So it looks like we are comparing 1/2, which is 32 64ths, and 35 64ths. And I'm looking at the numerator because that tells me the number of pieces that I'm considering. Looks like 35 is the larger of the two fractions. Questions about that process so far? Okay. Let's go ahead and do number 3 then. So number 3, if I look at the fraction with a smaller denominator, if I look at the 3/4, there isn't really a nice number, a nice whole number that I can multiply 4 by to get 15. And similarly with the larger one, there's not a nice number that I can divide 15 by to get 4. Sometimes you have to multiply both fractions by some number. It's not necessarily the same number. And to do that, you want to find some number that is a multiple of both denominators. So a multiple of 4 and 15. And yes, I see 60 in the chat. That's great. So 60 is a multiple of both 4 and 15. Multiple of 4 and 15. Or you could think of it a different way. You could say 60, you could divide evenly by 4, and you could divide evenly by 15. Once we have that, we can rewrite both fractions with a denominator of 60. This is what we would call the least common denominator. There we go. So I have 3/4, and I want to multiply this fraction, top and bottom, by a factor that will give me 60 in the denominator. 3 times 15 is 45. 4 times 15 is 60. That's the first fraction. Second, 11 over 15. I'm going to multiply the denominator by 4, which means I multiply the numerator by 4. So that will give me 44 over 60. Okay, great. So these are very close. It would be hard to just eyeball this as far as a measurement, but we can tell that 45/60 is larger than 44/60, therefore 3/4 is larger than 11/15. Okay. We all right with that? Yeah, I appreciate the chat. Looks like you are paying attention. Great. Okay. Let's go ahead and let's talk about the reverse of this. So we can create equivalent fractions by multiplying the numerator and the denominator by the same thing. We can do the reverse direction. So we can reduce a fraction by dividing the numerator and the denominator by the same factor. And this is helpful because, as mentioned, there are often several different names for the same measurement. And so if we want to not get confused, it's often helpful to express a measurement in what's called lowest terms. And to do this, we reduce or simplify the fraction by dividing the numerator and the denominator by a common factor. So as an example, let's start with 6/18. And I want to think about, is there a common factor in the numerator and the denominator? Let me zoom in a little bit. So I want to ask, what factor do 6 and 18 have in common? You don't have to get fancy necessarily. We could note that both are even. So I could divide the top and the bottom, or the numerator and the denominator, by 2. And that gives me 3/9. So it gives me a smaller denominator and a smaller numerator as well. This looks a little bit simpler. This is a reduced fraction for sure. I do want to examine my reduced fraction, however, and ask, well, do the numerator and the denominator have any common factors? Have I reduced completely? In this case, 3 and 9, again, have common factors. So I am going to choose to take that 3/9 and divide the top and the bottom by 3. So I can do that process again. 3 divided by 3 is 1. 9 divided by 3 is 3. Okay, so we have reduced this to 1/3. I can again examine my fraction and ask, do the numerator and the denominator have any common factors or any common whole numbers that I can divide them by? 1 and 3 do not, except for 1. I can always divide the top and the bottom by 1. But if that is the only common factor, then we have fully simplified our fraction. At this point, 1/3 is fully simplified. Let's do a few more of those. Let me go ahead and make a note here, though. We did this process above in 2 steps. We could have done it in 1. I could have noted that 6/18. Again, I'm asking myself, is there a common factor for the numerator and the denominator? A common thing I can divide the numerator and the denominator by. We chose 2 above. We could have instead chosen 6. I could divide the numerator and the denominator by 6. Yes, great. See that in the chat. 6 divided by 6 is 1. 18 divided by 6 is 3. And so we did that reduction in 1 step instead of 2. You should get to the same final answer regardless of how many steps you do. Doesn't matter to me whether you do the 2-step or the 1-step in a problem like this. But it's kind of helpful to know that there are multiple ways of doing this. Okay. Let's think about this. Let's identify which of the following fractions are in lowest terms, or which of the following fractions have a common factor that I can divide the numerator and the denominator by. If a fraction is not in lowest terms, we want to reduce it. So that is our goal here. Let's look at 3/8. And I want to ask, is there a common factor that I can divide the numerator and the denominator by, except for 1? In this case, there is not. Therefore, I can say that 3/8 is already in lowest terms. Or might say it is fully reduced. I don't have to change that any to get it in lowest terms. Okay. 3/24. I can again ask myself, can I divide the numerator and the denominator by the same factor? And yes, I agree. I can divide the numerator and the denominator by 3. 3 divided by 3 is 1. 24 divided by 3 is 8. So that gives me the reduced fraction 1/8. The numerator is 1. Its only proper divisor is 1. Therefore, I have fully reduced this fraction. Okay. Let's move to the next one. 3/32. The only factors of 32 are multiples of 2. So 1, 2, 4, not 6. 1, 2, 4, 8, 16, and 32. So those are the numbers that you can evenly divide 32 by. None of those are 3. Therefore, there are no common factors, no common number that I can divide the numerator and the denominator by. Therefore, this is already in lowest terms. So I can just leave it as it is. For larger numbers like 32, sometimes writing out the factors is helpful and doing a comparison. Okay. And now we can look at 6/8 and we can divide the numerator and the denominator by 2 because both of those are even. 6 divided by 2 is 3. 8 divided by 2 is 4. There are no other common factors. Therefore, 3/4 is our reduced fraction. Okay, let's move on to 8/32. There are actually a number of common factors here. I noted up above that 8 is actually a factor of 32. So what I could do here is I could divide the numerator and the denominator by that factor 8, which gives me 1 in the numerator and 4 in the denominator. That's doing this in one step. You could have done it in 2 steps. You could have done it in 3 steps. By starting dividing by 2 and then by dividing by 2 again. You would have gotten to 1/4 regardless. Okay. One more. Let's do 28/64. This one, those are not numbers that are as common. I don't use them as often, but I am noting that both numbers are even. So I'm just going to start by dividing the numerator and the denominator by 2. Let's just do that first reduction step and see what it gives us. 28 divided by 2 is 14. 64 divided by 2 is 32. Great. Looks like both numbers are even again. So let me divide by 2 again. Divide by 2, divide by 2. That gives me 7 on top and 16 on bottom. The only factors of 7 are 1 and 7. And then 7 is not a factor of the denominator 16. So we are done. That is fully reduced. Another way we could have done this is we could have divided by 4. And that would have done it all in one step, but we would have gotten to the same fraction in the end. So do whatever floats your boat, whatever makes the most sense to you. Any questions on those? Those making sense? Okay. So this process, great, thanks. This process of creating equivalent fractions, reducing fractions will be helpful. It is always a good idea to put your final answer in reduced form. Yes. Your quizzes, tests will ask that you have them in reduced form. And that's kind of the simplest form of the fraction. And it'll be the easiest to work with. Other questions about that? Okay. Let's do a little bit of application. Let's talk about tolerance. Which again, if you work in industry, you are probably more familiar with this than I am. But I can do fractions, and that's what a lot of this is. So tolerance is defined as the amount of variation permitted for a given length. Its mathematical definition is the maximum limit minus the minimum limit. It is informally kind of the amount of wiggle room that a manufactured piece has. If we're talking technical terms here, there are 2 types of tolerance that we're going to discuss. Both, first of all, have what's called a basic dimension. And that's the standard size from which the maximum and minimum limits are made. So it's how big a piece is supposed to be. From this, no machine is perfect. A certain amount can be added or subtracted in general. The unilateral tolerance means that tolerance is taken in only one direction. So unilateral tolerance here, I think this example is a shaft that is being put inside a hole. And if we want to consider unilateral tolerance for this example, the shaft can only be smaller, it can't be bigger. So it can only, we can only fudge it in one direction. Similarly, the hole can only be bigger, it can't be smaller. So that's an example of unilateral tolerance. Bilateral tolerance, on the other hand, means that the tolerance is divided partly above and partly below the dimension, and each piece can be a little bit smaller and a little bit bigger than the desired size. And that's pretty much what we're going to focus on is bilateral tolerance. I know unilateral has its place, but the bilateral is where we're going to land. For this example, let's zoom in a little bit. The shaft here, it has a base dimension, a basic dimension. Ooh, where'd my pen go? There it is. It has a basic dimension of 35.28 millimeters, and it has a tolerance of 0.01 millimeters, and that is above or below the 35.28 millimeters. So if I want to find the minimum shaft that will pass, I can take that 35.28 millimeters and I can subtract 0.01 millimeters, giving me 35.27 millimeters. So that is the smallest that the shaft could be. And then the maximum shaft, we're going to take that basic dimension of 35.28, and we're going to add the tolerance of 0.01, giving us 35.29 millimeters. And you can do that in your calculator or by hand, either way. We could do something similar with the hole. The hole here has a basic dimension of 35.24 and a tolerance of plus or minus 0.01. So the minimum for the hole, minimum will be 35.24 minus 0.01, which is 35.23 millimeters. And then the maximum possible size for that hole is 35.24 plus 0.01 is 35.25 millimeters. So there's a little bit of fudge in this, a little bit of wiggle room for this to pass as acceptable. Questions on that concept so far? Okay. So here the basic dimension and the tolerance are given in decimal form. Let's do some in fractional form since we're talking fractions. Let's see here. This will give us some practice on adding and subtracting fractions. So as a rule of thumb, when we are adding or subtracting fractions, we want to have the fractions, or we want to work with fractions with the same denominator. So we first make sure the fractions have the same denominator, and then we add or subtract the numerators and leave the denominator as that common denominator. For example, let's say I have a shaft and it has a basic dimension of 3 5/8. This is its basic dimension. And it has a tolerance of plus or minus 1/8 of an inch. This is the tolerance. We want to find the minimum limit and the maximum limit. To find the minimum limit, we're going to take the basic dimension, 3 5/8, and we're going to subtract the tolerance, 1/8. We can note here that we're taking 3 inches plus a little bit, a part of an inch, minus a part of an inch. So the number of whole inches remains. I can note that if I want to subtract one fraction from the other, they have the same denominator, which they must if I want to subtract fractions. I'm going to subtract specifically the numerators. So 5 minus 1 is 4, and then that numerator of 8 just gets carried along. It does not change. So 3 5/8 minus 1/8 is 3 4/8. We just talked about reducing fractions. We should probably try to reduce that fractional part. We can divide the top by 4, divide the bottom by 4. That gives us 3 1/2 inch. So that is the minimum limit. Okay. We can do something very similar to find the maximum limit. I'm going to take that 3 5/8 inch, and I'm going to add the tolerance instead of subtract the tolerance. We can note again, these two fractions have the same denominator or a common denominator. So the whole part comes along for the ride. I add the numerators, 5 plus 1 is 6. The denominator stays. And then I want to reduce by dividing the top by 2, dividing the bottom by 2, giving me 3 3/4 of an inch. 3 3/4 is the maximum limit. So the idea of tolerance and adding, subtracting fractions both come into play here. Okay. This example had fractions that already had a common denominator. We should probably talk about one where the fractions do not have a common denominator. Do an example with that. And we can note that when we are adding and subtracting fractions that don't have a common denominator, we can use our knowledge of equivalent fractions. So we can use what we talked about earlier to rewrite those fractions with a common denominator. So I have a basic dimension of 5 1/4 inch. And then I have a tolerance that has a different denominator of 1/16 of an inch. I'm going to begin by just rewriting everything with a common denominator. Let's start with the 5 1/4 because that 4 is the smaller denominator. This one, I can multiply the numerator and the denominator by 4, and that gives me 16 in the denominator. And then both dimensions have a common denominator of 16. I think it's often easier to start there, which is rewriting everything with the denominator that I need. Once I have that, I can find the minimum. Minimum limit of this is 5 4/16. I'm going to subtract 1/16. We already rewrote these so that they have a common denominator. 5 4 minus 1 is 3/16 is the minimum limit. And it looks like it is in inches. 5 3/16 inches. Units are helpful here. And second, the maximum, 5 and 4/16. We're going to add 1/16, which gives us 5, and 4 plus 1 is 5/16 inches. That is the maximum limit. 5 and 5/16 inches. Okay. Questions about either of those problems or this process? We are going to do some more examples, but we have one concept to talk about first. Okay. Sounds good. Let's talk about mixed numbers. As a definition, a mixed number is a whole number plus a proper fraction. So a whole number, the example you're given below is 5. A proper fraction is a fraction where the numerator is smaller than the denominator. So proper, oops, that was supposed to be a highlighter. A proper fraction. The numerator. The numerator less than the denominator. Or the top is smaller than the bottom. If I want to take a mixed number like this and rewrite it as an improper fraction, improper fraction would be the numerator is larger than the bottom, as you can imagine. It's the opposite of a proper fraction. Then I can do the following process. I'm going to take this whole number part and I'm going to multiply it by the denominator. So I'll take 5 times 4, and that gives me 20. That 20, I am then going to add to the numerator. 20 plus 1, that gives me 21. This 21 is the new denominator, excuse me, not the denominator, numerator. Let's get my fraction terms correct. The new numerator of the improper fraction. The improper fraction. And the denominator stays as 4. Or put another way, 5 and 1/4, we could rewrite as a improper fraction as 21/4. Again, those two mean the same thing, but they are written in two different forms. Sometimes the improper fraction form is preferred. Sometimes the mixed number form is preferred. It just depends on the context. Okay. You can see this using a ruler. I'll zoom in a little bit. 5 whole inches plus another 1/4 inch, or 5 and 1/4, is the same as 21 little 1/4 inches. So those are the same length. So if you want a visual, you can use a ruler to see that. So that's how to go from mixed number to improper fraction. What about the reverse? Let's talk about the other direction. If you want to change an improper fraction to a mixed number, you can use long division. 49/6, that fraction line is just another way to write division. So this means 49 divided by 6. You can interpret it like that. And so if we want to use long division to rewrite this as a mixed number, then I'm going to divide 49 by 6 and ask how many whole 6s, or how many times will 6 go into 49? How many whole 6s are in 49? How many whole groups of 6 or whole 6s are in 49? And the answer to that is 8. I can take 6 out of 49 8 times, or I could take 6 groups or 8 groups of 6 out of 49. That doesn't give me the whole of 49. It gives me 48, but then I have this leftover. This leftover 1. The whole number of 6s that I took out of 49 becomes the whole number part of the mixed number. The leftovers becomes the numerator of the mixed number, and the denominator stays as 6. It did not change. If you want to think about this informally, you could think you've got crates that hold 6 cans. How many full crates can you fill with 49 cans? You could fill 8 of them, but then you would have 1 lonely can left over. So you have 8 1/6 crates. Sometimes putting it in a practical example gives it a little more meaning. Questions on that? Okay with that? Okay. Well, let's do another tolerance example. Because sometimes when we are adding mixed numbers, we have to regroup. We want to find the maximum minimum values again of the shaft. And here we're given a basic dimension of 4 15/16 and a tolerance of 1/8 of an inch. So I'm going to start again by rewriting everything with the same denominator. So let's focus on the 1/8. Excuse me. I want to rewrite this with a denominator of 16. So I'm going to multiply the denominator by 2, multiply the numerator by 2. 1 times 2 is 2. 8 times 2 is 16. Great, we've got the tolerance. That tells me how to find the minimum value. The minimum tolerance, or minimum limit, excuse me, is 4 15/16. And then I'm going to subtract 2/16. So that becomes 4 15 minus 2 is 13/16. Okay, no issues there. 4 3/16 of an inch is the minimum limit. It's when we try to find the maximum limit that it gets a little strange. So let's do that now. To find the maximum limit, we would take 4 15/16, and we would add 2/16, which is the tolerance. We can do that in the same way that we did the above couple of examples. 4 whole inches, and then 15 plus 2 is 17/16. But now we can note that this fractional part of a mixed number is an improper fraction. This is improper, which means the numerator is bigger than the denominator. We generally don't prefer an improper fraction in with a mixed number. It can either go by itself, or we need to change it to mixed number form. So let's change this to a mixed number. 17/16. We can take 17, divide that by 16, and ask how many whole 16s are in 17? Well, there's 1. And then we have 1 left over. So this is 1 1/16. Therefore, 4 17/16 becomes 4 plus 1 1/16, which is indeed 5 1/16. And as I see in the chat, great. So that is the maximum limit of this. 5 1/16 of an inch. Great. Questions on that? We feeling okay with that? Okay. Great. Let's do one more tolerance example. Because, oops, let's not do that. Because there's one more situation we should probably deal with. Sometimes when we're subtracting numbers, instead of converting to a mixed number, instead of having something too big or an improper fraction, we might need to borrow. So let's do at least one example of that. This one has, again, a basic dimension of 5 and 1/32. It has a tolerance plus or minus 1/16. So let's start again by just rewriting this so that everything has the same denominator. 1/16. That's the smaller denominator. I'm going to multiply the numerator and the denominator by 2. 1 times 2 is 2. 16 times 2 is 32. Great. So we have the tolerance with the same denominator as the basic dimension. Let's find the minimum limit, excuse me. So I have 5 and 1/32 minus 2/32. We're talking inches here. So negative numbers don't really make sense in this context. If I tried to subtract those two fractions, 1 minus 2 would give me -1. I can't really do that. So maybe let's rewrite this. I'm going to rewrite it vertically. Sometimes that helps with visualizing. I have 5 and 1/32 minus 2/32. I'm going to borrow 1 inch from the 5. 1 inch is equivalent to 32 32 of an inch, which means I have 33 32 in the fractional part now to work with. If I borrow that 1, now I can subtract. 33 minus 2 is 31, and then the denominator of the fraction stays the same. I can just bring my whole number part down. So this becomes 4 and 31/32. Great. 4 and 31 32 of an inch. So that will occasionally happen with these. We can also find the maximum. Maximum doesn't really give us much trouble. 5 and 1/32, we add 2/32, and we get 5 and 3/32. No reduction needed there. There are no shared factors between 3 and 32. So we've got the maximum. Okay. Y'all okay with that? Now, fractions are nobody's favorite, but here they are.
I have a question.
Okay.
Why did we not make the 1 or 2 instead of doing 33?
Good question. So here, let me do this to the side here. If I borrowed 1 from the 4, then that gives me 32 32 is what that gives me. But then I still have the 1/32 on the right that I can't just get rid of. If I add the 32/32 plus 1/32, that gives me 33 32. So that's my fraction on the right. Does that make sense?
Yeah.
Okay, awesome.
Thank you.
You're welcome. Other questions about that one? Okay, great. Well, that being said, if you have that suggested calculator, the TI 30XIS, guess what? It has a fraction key. So you can actually do this process without having to convert and then convert back. It will do the process for you. The fraction button, I'll zoom in a little bit. It looks like A, B over C. If you type in this problem on the right into the calculator, then the 4 3/8 is going to look like this. The 2 3/4 is going to look like this. Add them together, you're going to get 7 1/8. It'll do all those conversions for you. I am totally fine with it if you do this on a calculator. I will warn you that some computer calculators don't have this option. And the Verity calculator also does not have this option. So if you're used to this and then go to the test and don't know how to add fractions, you might be in trouble. But if you have this handheld calculator, it will do this work for you.
Would we be able to use the second key function to turn it from a whole number into an unwhole number when we have the fractions?
So to turn it from a fraction to a decimal, in other words?
I believe so, yeah. I think that's way, yeah.
Yes. Yes, you absolutely can. That
Okay.
is actually on my, that's the next thing we're going to talk about.
Okay.
Yes,
Just wanted to ask.
totally.
Can we use the calculators for the test or no?
You can.
Okay.
Yes. In fact, I recommend that
Just
you use
not
a
a graphing calculator,
You can use a note card and a calculator.
but no graphing calculator.
Correct. No graphing calculator.
Got it.
Just a scientific. One thing I will also mention is the calculator will multiply, divide fractions for you. We're not going to talk about this process in class and how to do it by hand, but if you ever need to, the calculator has no issues with that. If you want to know how to type in this into your calculator, for example, how to type in the 4 3/8, you would type 4, and then you would hit that A, B over C button, and then you type 3. Again, hit the A, B over C button, and then you would type the 8 and hit the A, B over C button. So it's a lot of buttons, but it's workable. Okay. And again, that's not on the computer calculator, but it is on most handheld calculators if you want to invest in one. Okay. And yes, speaking of, you can change fractions to decimals fairly simply using a calculator. There is a button that will allow you to do it on the calculator, but because of this fact that a fraction is really just indicative of division, 5 over 16 means 5 divided by 16, you can change a fraction to a decimal by dividing the top by the bottom. We can take 5 divided by 16, and we get 0.3125. So that's the decimal form of 5/16. An alternative to that is that TI calculator that I mentioned has this fraction to decimal key. You will need to hit the shift button or the second button to utilize it. But if you have something written in fractional form, you can hit that F to D key and it will change the form to decimal form, and vice versa. If you have something written as a decimal, it will change it to a fraction. So you can use that whenever you have your calculator. I do recommend that you know how to change fractions to decimals in this form, because this any calculator can do. Doesn't matter how simple the calculator is. The right-hand one takes a specific button on your calculator. Questions on that? Okay. We want to be able to go backwards. as well. So we talked about the calculator key. So if you have that specific calculator or other similar that has the fraction to decimal key, then you can take a decimal and you can rewrite it as a fraction. If you don't have that, then I want to at least briefly talk about how to change decimals to fractions. We're not going to emphasize this, but I think it's worth stating at least once. If you want to write a decimal as a fraction, then first of all, you want to write the non-zero digits in the numerator, count the number of decimal places that you had to move to get to write that as a whole number, and write that number of zeros following 1 in the denominator, and then reduce. For example, let's say I want to write 0.46 as a fraction. Then I'm going to take this 46, this part to the right of the decimal point, and I'm going to write it in the numerator of the fraction. I can note that in order to write that as a whole number, I had to move the decimal point 1, 2. I am going to make the denominator of this fraction 1, followed by 2 zeros for the number of decimal points that I moved it. So at that point, we have it in fractional form. We can then reduce by dividing the numerator and the denominator by 2, giving us 25/50. Questions on that? Okay. As mentioned, I am not going to ask that you know that process. Give me 1 second. Sorry, I have someone at my door. All right, we're back. I'm not going to ask that you know this process, how to change from decimal to fraction, but what I do want you to know is how to convert a decimal to what's called a measurement fraction. So let's talk about that. A measurement fraction is a commonly used fraction. So it's most common to work with halves, quarters, eighths, sixteenths, etc. And it's often helpful to be able to determine, okay, if I'm given a decimal, if I calculated things in my calculator, how close is it to, say, a 64th of an inch? Because that's what is on my ruler. To convert a decimal measurement to the nearest 64th, we're going to do 3 steps. We're going to first multiply the decimal part of the measurement by 64. So that's first step. We're going to write this as the numerator of the fractional portion of the measurement, and the denominator will be 64. And then as a last step, we want to reduce if necessary. For example, let's say we want to convert 5.189 inches to the nearest 64th of an inch, which is kind of the smallest thing that a ruler will give us. I'm going to take that decimal part, so that part to the right of the decimal point, and I'm going to multiply it by 64. 0.189 times 64 is 12.1216. What this tells me is the number of 64ths represented by 0.1894. So this is the number of 64ths of an inch. Okay. I am going to write that as the closest whole number that I can. So what this means is the 5.189 5.1894 becomes 5 and 12.1216 64ths. That's what that indicates. It's kind of funny to have that decimal on top. I would prefer to not leave it like that. So I'm going to round that to the nearest whole number, which is 12. That pen's not working here. Here we go. Rounds to the nearest whole number, which is 12. 2.126 is closer to 12 than it is to 13. So that becomes 5 and 12 64ths. So I've written that as I've written it from decimal form to the nearest 64th of an inch. I do want to reduce, so I want to divide the top and the bottom by 4. That's the common factor, so that gives me 5 and 3/16. So 5.189 is closest to 5 and 3/16 of an inch on a ruler. Questions on that part? How did I get 12.1216? Great question. I multiplied that decimal part of the 5.1894 by 64. That's kind of the key step to this one. So it's a good one to ask about. We'll do a couple more of these, so don't freak out if you didn't catch this one first time. Okay. Let's do a couple more. We want to convert 7.9451 inches to the nearest 64th of an inch. To do that, and I think I'm going to do that above, a little more room above. I'm going to take this decimal portion, so this portion to the right of the decimal point, 0.9451, and then I'm going to convert it to 64ths. And I'm going to do that by multiplying by 64. 0.94151 times 64, do that in my calculator, and I get 60.4864. So that's the number of 64ths that this is, which means 7.9451 is equal to 7 and 60.4864 over 60. Okay. I don't want to leave that numerator as a decimal. I want to round that to the nearest whole number. 60.4864 is closer to 60 than it is to 61. So I'm going to rewrite it like that. This is 7 and 60. Wait a minute. See an error here? The denominator should be 64. I apologize. The denominator is always 64. There we go. And now we have 7 and 60 over 64. There we go. So we have effectively converted that to 64ths. We want to reduce. Don't want to leave it in that form. 4 is again a common factor, top and bottom. That will not always be the case, but it has been for the last two problems. So this is 7 and 15 over 60. So this particular measurement is closest to 7 and 15/16 of an inch. Questions on that? Okay. Let's see, we have 5 minutes. So for the sake of time, I was gonna have you do a problem, but I think I'm gonna do this next one. We have a couple things yet to do. If we want to convert 9.4495 inches to the nearest 64th of an inch, then I'm going to look at the decimal portion here. Oops. 0.4495. Multiply that by 64 to get it in 64ths. That gives me 28.768. Okay. That means that 9.4495 is equal to 9 and 28.768 64ths. I've just converted it to 64ths. I don't want to leave the decimal on top. 28.768. I'm going to round that to the nearest whole number. This time I'm going to round up. 28.7 is closer to 29 than it is to 28. Therefore, I can round this to 9 and 29 64ths. I can't reduce this time because there's no common factor between 29 and 64 except for 1. Questions on that one? Or the previous one? Is this process making sense? Okay. Well, I do want to do at least one application. Let's do a practical example. Practical example 1. I don't think we'll get to the last example. So practical example 2. But if you want to see that worked out, it is in the videos from 2020. So you should be able to find it in there. Now this one, this is kind of an example of thinking mathematically. In applications like this, I find it helpful to think about 2 things. First of all, what are the quantities given? And second, what are the mathematical operations that we need to answer the question in the problem? So this setup says there are 16 grooves that are machined on a plate as shown below. Not all the grooves are shown, just shows a portion of it to help us get an idea of what's happening. All the grooves are equally spaced. We want to find the center to center distance, dimension A. So we're going to find dimension A right here to the nearest 64th of an inch between 2 consecutive grooves if dimension B is 24 and 3/4 of an inch. Okay. So we've got 16 grooves in total. They're all equally spaced. We don't know dimension A. That's what we're trying to find. But we do know the center to center distance of the ends. We know dimension B, excuse me. So our goal is what? Our goal is, we could walk through this process and say, well, we want to take that total distance of 24 and 3/4 of an inch. Well, maybe we do. My iPad is freaking out. 24 and 3/4 of an inch. And we want to divide it evenly into segments. So we want to divide it into equal segments. Divided into equal segments. So that gives us an indication of the mathematical operation that we need. We're going to need division. So we have kind of on the picture gathered our information. We have an idea of the mathematical operation that we needed. One precaution for these types of problems is we want to think about what do we divide by. We can note here, for example, let's say I have these 2 grooves, and we want to think about how many spaces are in between those 2 grooves. There's only 1 space. Similarly, if I think about, say, 4 grooves, these 4, and we consider how many spaces are in between those, well, there's 1, 2, 3 spaces between those. So it looks like if I want to divide this into 16, or excuse me, if I want to divide this into pieces and there are 16 grooves, looks like there are only 15 spaces between those, and I'm cutting on the groove. So I really want to divide by 15, or one less than 16. So let's do that. 24 and 3/4 of an inch. I see the time. I'll do this quickly. Divided by 15. I can convert the 24 and 3/4 to decimal form as 24.75 and divide that by 15, which gives you 1.65. That's the decimal form. I want to convert that to the nearest 64th of an inch. 0.65 times 64 is 41.6. So 1.65 is equal to 1 and 41.6 over 64. 41.6 is closest to 42. So it's 1 and 42 over 64, or 1 and 21 over 32 if we reduce. So that means dimension A is 1 and 21 over 32 inches. Any questions on that one? Okay, I think we're out of time. So
Will we learn more about this next class too on Tuesday?
more about which part? Like more about the
The
practical
practical
application?
application.
We're going to be doing some practical applications throughout.
Okay.
Similar form. So yes, in that case, we are. You can also look at past semester videos. There's at least one more example in past semester videos. So this one's a little bit more difficult. This is not the type that I would ask you to do on a test, but it's worth going through.
Okay, thank you.
You're welcome. And you are free to go. I am getting some questions about talking afterwards. I'll hang out for a few minutes if you have questions. Otherwise, I will see you next week.
The videos are at the bottom, like in I'm lost for words. Down there where the modulars are, it's towards the bottom, right? Or
The videos are in the modules, yes. Let me show you where they are real quick.
Would it be the one that says view course stream?
Let me check because I don't remember exactly what it was. You can view them in a couple of different places. So let's see. Let's jump on to, I don't want that. I want this. Let's jump onto here. If you go to start here, and then you go down to up to test 1, and you look at the schedule and lecture notes, they're linked in there at the bottom. So recorded lectures from previous semesters. I will also post a recording of this lecture directly in the module if you want to look back at it. But if you want them tonight, then you can always look at these recorded lectures. Okay. Other questions?
Yes, between now and Tuesdays, we can take the quiz at any point, right?
Yes.
Okay, cool. That
Yeah,
was all
it's
I was wondering.
open. It is ready for you. You can take it between now and Tuesday or after Tuesday. Take your pick.
Awesome. Thank you.
Thank you. Have a good one.
You too.
thank
I
you.
have tried it on 3 different
Thank you.
computers
Have a good day.
with 2 different operating systems. And at the school itself, because I had a class yesterday as well, so I logged on and tried it, and they've all only got 6 questions on the quiz. I don't know what to do here because I'm, you know, I want to make sure I do well in this class.
Right.
And it's not offering me that seventh question,
Mm-hmm.
but it's counting it against me.
Yeah, I find that odd because I only put 7 questions on this quiz, or 6 questions, excuse me. There shouldn't be a 7th.
Because I'm getting
So-
all 6 questions correct on
Mhm.
3 different attempts.
Okay.
And it, you know, you look at the points on each question and it's
Mhm.
showing, you know, I'm getting every point for each question, but then it's only counting me 16 points out of 20 points. And it's marking me down as a 96% in the class instead of 100%.
Mhm.
Because at the beginning of the course, I sent you some pictures. It shows
Okay.
7 questions. To that email, a couple pictures that I screenshotted. I've done it from my phone.
Okay.
I did it from my home computer, which is Windows with Google Chrome. I
Gotcha.
logged on to school, you know, and I
Mm.
did it from an iOS computer I have here at the house as well.
Gotcha.
I don't understand, you know, why it's not giving me 100%. I don't know
Right,
if anybody
right.
else has had this problem. Yeah.
Let's see here. That is, okay. I'm looking at your highest score on the Canvas right now, just to make sure.
Yeah, it would have been 16 out of 20. So this question
Uh-huh.
7 must be worth 4 points. Or, you know, I had a couple other classes that were online like this, and I had something with the
Mhm.
Canvas does some weird stuff like this, and they had to, I don't know what they did to it, but they got it fixed.
Okay. Let me see here.
Because I go to work right after this, so I have to, and I work all the way
Right.
through Wednesday.
Yeah, that makes sense. That makes sense.
I guess I could.
Okay, I see what the emails that you sent me, so that's helpful. And I see, let me play around with it. I'm gonna give you, because I see that you got them all right on that one. I see that you got full credit or full points. So let me just go ahead and give you full credit for this quiz. And then I'll play around with it and get back to you.
Okay, I appreciate
That
everything.
sound good?
Thank you.
Yeah, thanks for letting me know.
I'll let you answer other questions now.
No, you're good. Other questions? Y'all who are hanging out?
No, I'm good. I was just listening to him in case I ran into the same problem.
Okay,
All
sounds
right,
good.
I'm good. Bye.
Sounds good. Okay. Cole, Zach, do you have questions? I don't want to close the Zoom call on you if you do. Okay, sounds good. We will end it then.